Students, this is the part 3 of the vector analysis. So in this video, I'm going to explain some properties of vectors. So first one, multiplication of a vector by a real number. So we can multiply the vector quantity by the real number. If you multiply a vector a bar by a real positive number n, we get the vector na bar, which has the same direction as a bar and magnitude na. So example, when a bar is a vector, when you multiply the a bar vector with a real positive number n, you will get na bar. That is also vector. So its direction as same as the direction of the a bar and its magnitude is na. So that is na bar is equal to n of a bar. Na bar is equal to n of a bar. The magnitude of the vector becomes n times while its direction remains changed. So only magnitude changes. When you multiply the vector with a real positive number, its magnitude changes. So n times of the given vector. But if the direction does not change, remains unchanged. So for example, if we multiply vector a bar by the number 2, we get another vector b bar which has the same direction as that of a bar, but at twice the magnitude. That means we can write b bar is equal to 2 into a bar. That means the direction of b bar also same as the direction of a bar, and the magnitude of the b bar is 2 times of the magnitude of the a bar. Second one, multiplication of vector by a scalar. Multiplication of vector by a scalar. If we multiply a vector a bar by a scalar, yes, the result is another vector with the direction of a bar but magnitude sa. If s is negative, sa bar is also vector. It has a direction opposite that of the a bar. So magnitude does not change, but direction opposite to a bar when we multiply the negative number or negative scalar. Another property, vector addition obeys commutative law. According to this law, the result of the vectors remains the same in whatever order they may be added. That means a bar plus b bar is equal to b bar plus a bar. So order is not important. A bar plus b bar is equal to b bar plus a bar. So we can say that vector addition obeys commutative property. Fourth one, vector addition obeys associative law. According to this law, the resultant of the vectors remains the same in whatever grouping they may be added. That is, a bar plus b bar of plus c bar is equal to a bar plus of b bar plus c bar. So grouping of vectors order does not follows. That means vector addition obeys associative law. Next one, resolution of vector. That is a splitting of a vector. The process of splitting a single vector into 2 or more vectors in different directions in a plane such that their sum gives back the original vector is called resolution of a vector. So for example, r bar is the vector. It is split into, resolved into 2 vectors in different directions. They are a bar and b bar. So r bar vector resolved into 2 non-parallel vectors a bar and b bar. So you can write r bar is equal to a bar plus b bar. So here a bar and b bar are the vector components of r bar. So a bar and b bar are called vector components of the given vector r bar. So rectangular components of a vector in a plane. When a vector in a plane is resolved into 2 components at right angles to each other, the component vectors are called rectangular components of the vector. For example, here a vector resolved into 2 components, horizontal and vertical. So horizontal denoted by the ax bar and vertical component denoted by ay bar. So here vector a bar in the xy plane, it is resolved into two rectangular components. They are ax bar and the ay bar. So ax bar lies along in the horizontal direction, ay bar in vertical direction. So we can write a bar is equal to ax bar plus ay bar. So here ax is equal to a cos theta. Ax bar is a vector, but ax is not a vector. It is this ax bar is a vector. Ax is its magnitude. Its magnitude is equal to a cos theta. Similarly, ay bar is vector, but ay is its magnitude, that equals to a sin theta. So magnitude of a bar. So we can find magnitude of a bar by using this formula. So magnitude of a bar, a is equal to root of ax square plus ay square. So we can express these vectors in terms of unit vectors also. Suppose this is I cap. I cap is a unit vector along x-axis. Cap means is the symbol for unit vector. Unit vector means its magnitude always 1. So j cap is also unit vector along y-axis. So j cap magnitude 1, its direction along in y-axis is a unit vector along x-axis. J cap as a unit vector along y-axis. So we can express the vectors ax bar and ay bar in terms of unit vectors I cap and j cap. So ax bar is equal to ax I cap and ay bar is equal to ay j cap. Here ax bar is the vector quantity, vector, but ax is not a vector, its magnitude, but I cap is the vector. So ay bar is vector, but ay is not a vector, it is the magnitude, j cap is the vector. So we can express a bar in terms of unit vectors. A bar is equal to ax I cap plus ay j cap.
Please do like, share this video and subscribe to our channel.